Okay, thank you very much. So yes, as we've just said, I'm going to be talking about the bare necessities of data science today. But there will be no bears discussed during this talk. But don't worry, there will be references to plenty of animals, especially koalas, and there'll be a lot of pictures of koalas. So what are we actually going to be doing today? Well, the bare necessities, I'd say, of data science include inspecting your data, being able to manipulate your data, and then visualizing your data. That's really going to help you get started with data science wherever you are on your journey. So who can do this, and who's the ideal audience for this talk? Well, maybe you're already a data scientist, but you want data scientist and you want to learn a bit more about Python and Matplotlib and Pandas, so you can do more with those technologies. Or maybe you're a developer who's launching into the world of data science. And maybe you're a teacher or a university lecturer and you want to be able to do some of your own data science and teach others, or you're teaching actual school students or uni students. They can do it too. This is perfect for everybody. These are actually some of the tools that I used when I was in uni, actually doing chemical engineering and stuff to do some data science way back then. So yeah, let's see what we're going to need today. We're going to be needing some koala data. So I've mentioned there's none of these are going to be bears. So we've got koala data, not bears. Pandas or pandas, the Python programming library for dealing with data. Also not actual pandas, which are also not bears. Python, which is also not a bear. Hopefully this is sticking with you. Python's not a bear. And finally, Matplotlib, which is definitely not a bear either. So there'll be no bears discussed during this talk, but we will be doing a lot of koala-related data science today. So I'm very excited to get started with that. So yes, if you've seen on here, there is a link, aka.ms/koala-repo. If you want to code along with me, or if you want to grab for later, have some code for later, then you can have all of this, and you can feel free to clone this repo. And I'm going to be working in a code space today that I've already got started working here. You can clone it and make your own code space and code spaces right here, which is really handy if you want to do some data science and just do it in the browser. So I'm going to be using a Jupyter notebook today. I am working on the demo_koala.ipynb. That's short for IPython notebooks, the original name of Jupyter notebooks. But all of the code that you might need later will be in the Koala Data Science notebook. So it's all going to be there if you want to have a go at that later. Or I'll push these changes up once we're done here today. So let me just get my own notes up so we can get started here. So yeah, firstly, as I've mentioned, we're going to be using Pandas today, which is a library for handling our data, because we've got some koala data here today. What we have is some koala sightings. So I'm just going to open up that CSV so we can take a look. This is not the most friendly way to actually have a look at your data. It's a little bit overwhelming. You can't really get a lot of nuance out of it right here. So we're not going to be looking at our data in this form today. We're going to be looking at it using Pandas firstly. So I've already installed Pandas, but I've got a requirements.txt file right there if you need to install it yourself. So I'm installing Pandas and Matplotlib. And you can use, just in the terminal, you can run pip install -r requirements.txt to install that whole file. So we've got that all ready to go. So now we're going to need to create a Pandas data frame. 1 second, I've just lost my notes on my other screen. Here we go, much better. Okay, so firstly, we're going to want to get the data out of that koala sightings _data.csv. So this is just how we can read some data using Pandas into a data frame. So that's how we're going to store all our data. It's kind of like if you imagine like an Excel table almost, but you have so much more functionality and a lot of different bits and pieces you can do to interact with that data. And it's just really easy, much easier than dealing with your data in CSV format. So it's going to be pretty fun. So I'm going to use this to read data from our CSV. And then I'm just going to print it out so we just have a bit of information about our data. So I'm using koaladata.info. So once it's in our data frame, we can just kind of start asking questions of our data using this .info right here. So let's give that a run. So firstly, we're going to import Pandas. you haven't used a notebook before, you just run one of these cells each at a time, just writing Python, and then it can just run each of them, and it keeps all of that in memory. And you can also run all of them from top to bottom if you ever need to do that. So we have now pulled our data from the CSV into a data frame, and it can tell us things like some information about our data. We could also ask it for the shape of our data. Let's do that first. Just a quick, easy one. Let's comment this one out and then rerun that. So super easy. We can just say, oh, here's the shape of our data. We've got 649 rows. So 649 different koalas have been cited in this data. And we've got 32 different columns, our different fields about the data. So let's uncomment that and run that again. And we can have a look at the info. So we can just ask it to tell us some information about this data. It's already looking a lot more friendly than looking at the whole CSV. So we can see the different bits of information we have for each of these koala sightings, like the year, the date, the age of the koala, the number of adults that were seen there, the location. We've got the LGA, the local government area. We'll be working with that in a little bit as well. So yeah, we've got a lot of different bits and pieces we could do here. And something I really love about data science is it's really just a way of asking a lot of different questions. Most of these questions, you'll go and do some investigation, and then you'll probably be left with more questions, but that's kind of the fun of it. So we've got our starting point of inspecting our data here. What have we got going on? What could we possibly do with this? So now we've got our setup a little bit. Let's have a little bit more of an explore of our data to see what are some of the things we might want to start looking at. So I'm going to just start by getting the names of the columns. We did have them up here, but actually there's more than can fit on this screen. They only prints out 18, and then it kind of tells us there's more and you could get them. So I'm going to get all of them. I can know a bit more about the names, because if we know the names of the columns, we can start addressing our data frame by those columns and doing some interesting data science with them. So here are all the names of our columns. So we can start going, oh, what might I want to do with these different things? So I'm thinking, okay, in this data, I could see that there was a lot of data and it's got different places in it. I kind of maybe want to know what different locations have been surveyed for koalas and where the most koalas are and things like that. So I'm going to say, okay, what locations are we looking at? How many different locations? Is it just like a really small area? I know that this data is from Queensland, which is a state of Australia, up in the northeast. It's a pretty I guess most of our states are pretty big, but it's a pretty big state with a lot going on. So let's find out where this data is from. Okay, so we've run this, and now we can see that our data is from these, how many locations? 8 locations, I think, are there. So we've got, Brisbane. You might have heard of Brisbane, capital of Queensland. We've also got the Gold Coast, just a bit south of Queensland. No, not south of Queensland, south of Brisbane, where my lovely partner is from. And yeah, we've got a few less metropolitan areas as well. So we've got a few different locations going on here. We could start thinking about, where might the koalas be? What might be going on here? Where could we consider there'd be a lot of koalas? So we've got all of that information there, but we just need to be able to get it out. So let's find out which is the most koala-y location in these Queensland locations. So I'm going to take first a look at the Gold Coast, where my lovely fiance is from. So we're going to look at how many koalas are in the Gold Coast. I'm going to call these my golden koalas. So we've got our golden koalas. Here we go. I'll just explain this bit of code here. So we've got golden koalas, and we're going to get the location of the koalas. And we're going to make sure it is equal. So we're going to say, hey, give me that koala data LGA. So we want to look at those columns, and we want to make sure it's equal to the Gold Coast. So we run that. It's going to tell us what koalas. We have to print something. That would be important. Let's print the golden koalas as well. I can tell you these are not gold-colored koalas. These are just koalas in the Gold Coast. And here we go. We've got all of our Gold Coast-based koalas that we've seen we can see they're in the bushland around the Gold Coast here. So that's good to know. We've and say, oh yeah, there's a bunch of koalas there. That's just a nice way to know that we can address specific areas. We can say, hey, I just wanted to get koalas for this location. And we're going to use a bunch of things like that going forward to kind of aggregate our data and do some visualization in a minute when we get to it. But just for, in case we want to be able to save our golden koalas for later, I'm just going to quickly show you how you can save your data, because maybe you're like, I don't actually care about Brisbane koalas. I don't care about Logan koalas. I only care about my Gold Coast golden koalas. So if you wanted to be able to export that data really easily, maybe to give to somebody else, we could just say to CSV. So we've previously imported from a CSV, but now we can just go to CSV, and we're going to make our new CSV called golden koalas. And I'm just going to run that. And then we will have here our golden koala CSV. So if you ever need to export your data, super simple like that, to send back on its way, back in the format that it came to you. Because Pandas is really great for working with data. And if you're working in a team, I can completely advocate for working with your data in regards to that. And you've heard a lot of different talks today. Maybe we've been talking about Fabric. I've heard a few of them about that. So you can work with similar notebooks like this in Fabric. And it'd be great if you're working together in Fabric with the rest of your team. But if you do need to send some data on its way, maybe to another organization, you can export it in a CSV just like that. So there we go. So we just wanted to know how many unique locations we are looking at. I think we did this earlier. So let's just run that again. Yes, we've already had that one. So those are our different unique locations that we have our data for. I think maybe we didn't run that earlier, but yeah, that is just a way of saying, hey, what were all our different headings? There we go. Yeah, we had that before. And we're going to be using that going forward, because we're going to learn to say, where are these koalas? How many are in each location? So really handy, say, hey, this is my data set I want to look at. I want this column, LGAs, and I just want unique ones. I don't want you to print me out all of the LGAs and then have Gold Coast repeated a bunch of times, Brisbane City repeated a bunch of times. I just want to know what all the individual ones are. So really handy if you want to, for instance, make a bar chart or something. So we're going to be doing that in just a minute. Okay, so let us visualize some data as well. So we've got a lot of different data going on here. And I think data science is a really interesting way. It's just really interesting for me as an adult, but I think it's also a really interesting way to learn to program, and to ask a lot of questions, whether you're teaching kids science, whether you're teaching them computing. There's so many different interesting things you can do with it. And it's fun to make some graphs that are really fun to interact with as kids, and just like visual representations of things that they understand. So we're going to try and make a few fun ones today, but we're just going to get started with the tree heights of the trees that the koalas have been spotted in, as well as the koala height in the tree. So how high up in the tree do they go? Do they like to go higher? I don't know. Maybe they always stay near the ground. Maybe they go to the top of the tree. So we're going to find out this using a scatter plot. So let's have a look at how to get our tree data. So we've got our tree heights variable, and we're getting our koala data, and super simple. We're just going to ask, please give me the height of the tree. And we're just creating a slice, essentially. We just want this column of data, because when we're going to plot our X versus Y axes, we do need to have those two bits separated. So a bit of this data finagling that we're doing is just getting our data and putting it in two little slices so we can plot them against each other. So firstly, we get the height of the tree. Secondly, we also want the height of the koala in the tree. So we're going to pop that in here as well. And then let's just have a quick look at what that looks like. As I said, it's just going to be a single slice of the data. So we can just kind of like how you would reference something in a list. Instead of using an index, you can just use a name, or for instance, actually in a dictionary is a much better example. You say, hey, I want this column of data, and it will just give us that column of data. So this is our koala heights in the tree. So that's all good. So now we've got those two bits of data. Let's make a plot. And as I said, we're also working with Matplotlib today, which we imported we installed with pip at the start in requirements.txt, but it's now time to import it. We're going to use pyplot to make some nice graphs. So let's start with a nice little scatter plot. Super easy. If you just want to make a single plot, you can just go plot.scatter. And so imported pyplot as PLT, which is very common in the Matplotlib space to just have that shortening of it. So we're going to get plot.scatter, and we just want koala heights versus tree heights. I'm going to have koala heights on the x-axis going across, and I'm going to have the tree heights kind of actually like representing the height of the tree going up the y-axis. I think that's fun. I think that's fun for the kids to understand if you're teaching it to students, whether they're kids or university students or just your friends. I think it's pretty cute. So let's give it a run, and then we can just export it. We can just see it right here in our Jupyter Notebook, which is super handy. So we can see here we've got different tree heights, and as the trees get taller, we do see the koalas actually going up higher in the tree. So when I see this, I kind of start asking a bunch of different questions, being like, I wonder how logging is impacting the populations of koalas, because koalas are endangered. That's why a lot of people around the world will know of koalas, not just because they're cute, but also because we're trying to save them. So if we're cutting down trees and the trees aren't as tall, are they less safe from wildlife? What's going on? Are they less safe from feral animals like cats and things? What can we do to help them? So yeah, that's something I really like about data science. So we've created that here, and yeah, you can go, okay, what else could we maybe want to know about our koala friends and their tree-based habits? Maybe what areas do they like the most? So let's take a look. As we said, we have different LGAs. How can we plot these to see which LGAs are the most popular for the koalas? What are the hotspots for koalas in Queensland? So I'm going to grab this line of code. And this one here is, we're going to get the koala sightings count. So what I want is how many koalas have been seen in each of these local government areas. So we get the koala data, and we want to group it by the local government area. So we want to put everything that's in Logan, they should be grouped together. Everything that's in Brisbane City, they should be put together. And everything that's in the Gold Coast, they should be put together. So grouping by that. And then once everything is grouped in those different LGAs, we want to do a count. So because we know the IDs are unique, I'm going to use that as the field we're going to count based on. And then we can just get how many different items are in each of those groups now. So if we do that, I'm going to also print it out. And it's going to give us a nice little table with just for those different LGAs, how many koalas have we seen there? So here we go. We've got a nice bit of data now. So it's looking pretty good. It looks like what we want it to look like, numbers and different locations. But it would look better if it was in the form of a bar chart, I think. So let us make that a reality. So we're going to once again separate those X and Y axes, because we've got what we want on our x-axis is x-axis here, and what we want on our y-axis here. But we do need to separate those into two different bits and pieces, because they're currently in koala sightings count, which is great because we can just split those out just like a dictionary. And we can say, okay, I want the keys, which are the names of the different LGAs, and I want the values, which are just the numbers here. And we can say, okay, now we've got our x-axis, which is the LGAs, and our y-axis, which is the counts. And we can start making a nice plot on that one. So making a bar graph here. We're going to hit run on that. But I may have forgotten to put actually our axes titles and our title for the graph on our last graph. But yes, as we can see here, it's looking a bit sad without those on it. It's also got this horrible situation going on here where we've got a lot of overlapping going on. So let's fix that up a little bit. We're going to start by giving it a title and some axes titles as well. So looking a bit better. Got a title, very easy, and adding our different axes for the X and the Y axes. But also we can do lots of fun things, like we can rotate these tick marks here, these little these axes tiles down the bottom using x ticks rotation equals 45. Just make it a little bit nicer, and we can do show. If you are running this in Python rather than in a Jupyter Notebook, you'll need to do show. Otherwise, it won't show it. It just happens to show it because it is the last thing that happens in this Jupyter Notebook, in this cell. So we've got this going on now. So that's looking way better. We can see that Moreton Bay has heaps of koalas. Redland City, tons of koalas too. And yeah, now we've actually got a good visualization for that, which is going well. Cool. So that's great. Let's go and see how tall the trees are in each of these LGAs, because I think that's going to help us understand possibly the state of the koala life in each of these LGAs. Maybe it'll show us something about why there's more koalas in Moreton Bay than in Noosa, but I don't know if it will. But it's just good questions to ask, and maybe if it doesn't, then it just leads us to ask more questions. Yeah, because there's always more data and there's always more nuance, especially when dealing with just the environment. There's so much going on there. So let us start by getting our tree data. And now this time we're going to group by the local government area again. But this time I want to get the average height, the mean height of the height of the trees for that LGA. So grouping again, but this time instead of doing a count, how many koalas have we seen there, we're going to do a height of the tree and get the average. So we're going to get all these bits of data and we're going to get the mean, and then we're going to store that for each of the LGAs. So we can print that one again as well. Tree heights mean. Cool. So looking good. Got some data going on there. That's the shape that we would expect it to be. Always good to have a look at your data, both when you start with the CSVs and throughout, to be like, is this what I was expecting? Because data is not always clean. It does need some cleaning up sometimes. So let us start by plotting a graph. So this time I'm going to do something a little bit different because I want to do a little bit of a fancy graph later. So I'm actually going to have two graphs here. And they're going to be on top of each other. So I'm going to use something called subplots just to start, because we want to put more graphs into this later. So it's a little bit trickier, but it's not very tricky. And we just need to set it up this way so we can have two graphs on it later. And once again, we are going to split out our data into our X and Y axes. So I'm just going to have X and Y for our tree heights, mean, keys, and values. And then I'm going to plot our bar chart here. And let's start by writing that. I'm going to make it brown because I want it to look like the trees. So we've got these little tree bars here, which is fun. And that's looking good, except for we don't have any titles, etc. Again, so let's whack those on and tilt those axes names as well. So we're going to make them vertical. Little typo there. Cool. So let's hit run and have that looking better again. Question in the chat: how does the data frame look after we add group by anything? So the data frame itself won't change. It's making a reference to that data frame. So that's going to stay the same. I see people are not liking this light colored VS code in the chat. That's okay. We just do that for the stream. It does make it more visually able to be seen by people, especially coming across the stream. It improves the definition. So I apologize for the white that it is coming at your eyes, but it is better for being able to see. But hopefully that is answering your question a little bit about the data frame after we add the group by anything. It stays the same. But yeah, it's mostly just a reference and creating a new reference to that data. A little like mini data frame essentially. Okay, so that's looking pretty good. We've got some tree heights for each of the LGAs. This is the average tree height for each of them. And obviously you could do a lot more with the different, like you could do a mode, you could do the median, you could do a lot of different things in here, but we're just doing this for simplicity today. You can do all manner of data science, all kind of statistics things here with your data. Okay, so now we've got our tree heights. I kind of want to add where the koala is in the tree to that. So how high are the koalas in the tree? We're once again going to do another average, another mean here to get the koala height in the tree, just like we did for the tree heights. And then we are going to add our koalas. So I'm actually going to be putting a lot of the same graph stuff in here because I just want to add to the ones we just had. So yes, once again, we've got our tree data here. and I'm going to add our koalas here. So I want to do a little scatter plot on top of my tree vertical bar graph. And then we're just going to add those axes labels as well. And let's hit run on that. And there we go. We can actually have our koalas as they are on average in the trees as they are on average represented on the same graph, which is, I think, a pretty cool thing. So yeah, that's most of it what I had to show for you today. I did want to try and get little koalas as emojis on here, which I have not quite been able to do because I'll show you quickly what we get if we do try and use a koala emoji, and then we'll see what we can do instead. Maybe we can implement the koala emoji in Matplotlib. We do not have koala emojis represented in Matplotlib, but we can instead use a different emoji of your choice here. So, which is, I'm going to use one thing again, a thing that is not a bear, because we don't have bear emojis. I thought that would be a fun way to end this session, but there are no bear emojis. So instead, we're going to have cat emojis in a tree to represent our koalas as where they are sitting in these trees. A bit ironic because cats may be part of the problem, but I think logging is mostly part of the problem. So yeah, hopefully you've learned a little bit about data science today. And if you want to learn a little bit more, you can check out any of these resources here. I've got a few episodes on data science doing more of this kind of stuff, touching the koala data a little bit, but also some other environmental data on my Code Garden video series on Microsoft Reactor YouTube. You can check out our 14 Days of Data Science blog. We're up to day 7 now, and there'll be 7 more days coming where me, Jasmine, and Nitya have been working on some awesome blogs that tell you all about things, all about machine learning and different stuff. And also there's a great data science learn pathway that you can check out on Microsoft Learn. These links are also all on the README for my repo, so you can check that out at aka.ms/koala repo again if you are keen to give it a go. Yeah, that's all I have for you. That's all my koalas here today. I hope you've learned one thing, that koalas and pandas are not bears as well.
That was so great. And we got both you and Nitya on the screen today, and Jasmine earlier today. She started off the episode, and that's the team have been really doing an awesome job with those 14 days of data science blog posts. I'm so excited that you were all able to contribute that. You were answering some questions in chat as you were going, but I had another one. And maybe if we wanted to bring back your last screen, but so you really wanted to focus on the fundamentals. I feel like I have a really great fundamental understanding of data science in Copilot after your presentation. But like, what would you imagine the next steps should be? What is involved in some of those more advanced presentations that you have?
That's a great question, because there's so many kind of different places you can go to once you've kind of got a few of these basics. Like, obviously explore more in terms of how you can do other statistics and stuff. But I think other things that I really enjoy, I've also got some things on 3D graphing potentially. Ooh. That's in one of my videos. So in my Code Garden month, I did introduction, just how to work with the data. So really just delving more into Pandas and what you can do there. Then there's a whole episode 2 on more of these different bar graphs, line charts as well, just having a full basis in all of those, and then going more into 3D graphing surfaces and things like that. I think that's another good spot to go to next. And then if you also want to branch out and go into more machine learning stuff, I think that's where I kind of went with my data science, was doing some more prediction-based things, and also being able to explain this, the statistics behind the probabilities of the likelihood of the different outcomes that you're predicting, which is really interesting, which I've done a bunch around environmental data, and graphing that with colors on different 3D surfaces, I think is a really fun direction to go in.
Yeah, I love the animals. I love the environment. I love those use cases. That's great. I love that. Thanks so much for joining us, Renee. I appreciate it. You have a great day. Happy Pi Day. Is it still Pi Day for you, or is it the day after Pi Day?
It's the day after Pi Day. It's pie hangover day if you eat too much pie, I guess.
That's great.
Yeah. So yeah, no longer Pi Day, but every day, not Pi Day.
Yes, there you go. We just need to pie every day, and then it doesn't matter.
That's
It was
it.
great. It was an awesome way to end the day. Thanks, Renee.
Thanks for having me. Have a great Pi Day, everyone.